So one more of these postulates where we can use pieces of triangles to tell that they're congruent. And let's go over it. What we're looking at is we had angle, side, angle, or ASA. Now we have angle, angle, side, also known as AAS Postulate. Okay? So we're looking for an angle, angle, side. And this is stated as, we need to read it very carefully. There's one other word I want to underline here and emphasize. This word corresponding. Okay? If two angles and a non-included side. Well, we know what included means. It means the one between, sandwiched in between. So non-included would mean the one that is not between. Well, if I've got two angles, how many sides are not between those two angles? Well, there'd be two sides, right? So either one of those. Okay? So if I have two angles and a non-included side of one triangle are congruent to the corresponding two angles. Oh, corresponding. That means they have to be, according to CPCTC, they have to be corresponding or in the same direction, same location as the first triangle. So, if two angles and a non-included side of one triangle are congruent to the corresponding two angles and side of a second triangle, then the two triangles are congruent. Well, let's see how this works and see if we can put that together. Okay, so here is an example of two triangles. We have triangle ABC again, wearing that one out, and triangle XYZ. Now we marked angle A and angle B, and those are congruent to angle X and angle Y. And then the non-included side. Now we could have chosen AC or BC. I chose BC. And that corresponding, notice that X corresponds to A, Y corresponds to B, and segment YZ corresponds to segment BC. So those corresponding things have to be there. And because that is true, by angle, angle, side, or AS, triangle ABC is congruent to triangle XYZ. And using CPCTC and our nomenclature here, we can state, put those over each other, line them up, and we find out that A corresponds to X, making angle X, angle A, congruent to angle X. Angle B and Y line up, so that's angle B is congruent to angle Y. Angle C is congruent to angle Z. And AB corresponds with XY, so therefore segment AB is congruent to segment XY. Segment BC corresponds to segment YZ, therefore those two are congruent, and segment AC corresponds to segment XZ, and they are congruent, all according to CPCTC. Okay, so we've gone through 4 of these. Now let's do an example of proving this so we can see how it's actually used. Okay, let's look at this and see if we can use the AAS postulate to prove some things. We've got a figure over here, has 2 triangles in it, ABC and DEC. We're given that AB is parallel to ED. So let's mark that. AB, okay, is parallel. Well, that really should be, let's redo that to make that correct, to DE. Okay, so these two are parallel. Okay, let's put our arrows there, denoting that they are parallel. Okay, so they're parallel. Big deal. What does that mean to us? Well, if we were to extend these lines, pretend that they go on forever, and come along like this, okay, we begin to see, wow, 2 parallel lines cut by a transversal, don't we? Interesting. Let's go to the next one. C is the midpoint of AD. Well, if C is the midpoint of AD, that means it does what? Bisects AD. Bisector cuts to something in half, creating two equal or congruent pieces. So that means that this is congruent to this one. Okay? So now what we need is our two angles. Well, wow, look at these two angles. Angle ACB and angle DCE. What do we know about those two angles? The non-adjacent angles of intersecting lines. They're congruent. How? Because they're vertical angles, the vertical angle theorem. So we need another side, but that side, or we need another angle. That angle cannot be here because that would make this side the included side. And we need a non-included corresponding side. Well, this corresponds to this, so that means it has to be this angle here. So somehow we have to prove that this angle is equal to that. Well, we have two parallel lines cut by a transversal. Tell me about this angle, angle E, and angle B. What is the relationship between those two angles? They're between parallel lines cut by a transversal. They look like they're on alternate sides of the transversal, and they're inside, so that would be alternate interior angles. So alternate interior angle theorem says that, wow, alternate interior angle theorem says that those two angles are congruent. So we have angle, angle, non-included side corresponding, angle, angle, non-included side corresponding. We ready to go? Well, let's try this thing and see if we can make it happen. Okay, and to start with, we're going to set this up and we're just going to say triangle ABC and triangle DEC. Line them up so we know what goes with what. A goes with D, B goes with E, C goes with C. What are we given first? AB, segment AB is parallel to segment DE. And we're given that. Okay? How do we use that? Wow, we can just simply say what? Angle ABC is congruent to angle DEC. Why? Alternate interior angle theorem. Two lines are parallel and cut by a transversal. The alternate interior angles created will be congruent. Wow, look at that. That gives us an angle. Now, next thing, if we go up, we need another angle, don't we? Wow. So let's go. Angle ACB is congruent to angle DCE. Why? Vertical angle theorem. Got two angles. Next one, let's get this given in here. C, midpoint, A, segment AD. Why? They told me so. So what does that tell us? That tells us that segment AC is congruent to segment DC. Why? Definition of midpoint. Okay? So we've given that proof and we've done that proof. Now, let's extend that proof just like we've done the others and say that they want to come in and say, well, we want to know that angle A is congruent to angle D. So prove that angle A is congruent to angle D. Well, what would we do? We'd simply come over here, add this, and we'd say, yeah, that's right. Angle A is congruent to angle D. Why? Well, because those Whoa, we haven't done our triangle yet. Let's get our triangle. First, getting ahead of ourselves. We'll get back to this. Okay, let's get our triangle in there and then we'll go from there. So here we have our side, oops, wrong color. Here we have our side. So we're ready for number 6. Okay? That triangle ABC is congruent to triangle DEC. Why? AAS Postulate. Now let's extend it, okay? Let's extend this and see where we go with it. We want to come down and let's say they extend this and they say, well, we really want to know if angle A is congruent to angle D. Wow. All we have to say is because those two triangles are congruent and because of CPCTC, then statement 7 would simply say angle A is congruent to angle D. Why? Because of CPCTC. So we would have extended that. Okay, so what we've gone through in sections 4.4 and 4.5 is 4 different ways that we can prove that two triangles are congruent when we have not been given all of the pieces are congruent. So we can prove that those are. And notice that these are statements. These are postulates. Postulates are statements that do not have to be proven. Okay, now we could prove those. It wouldn't be too difficult to do that. But those would be bare bones basics that we go from. Okay, these are very important postulates for you to remember. We'll look at some others here.